Another method for the preparation of amines is via reductive amination. I think it's one of the more interesting reactions that we'll learn about this semester. So instead of using NaBH4, which we've learned about to reduce aldehydes and ketones, we're going to use NaBH3CN, sodium cyanoborohydride. And I'm going to rewrite that because it sounds a little better. But you can write it either way, sodium cyanoborohydride. When we mix all of these together, the intermediate, as we learned about in the aldehydes and ketones chapter, is this imine. And it gets reduced via NaCNBH3, sodium cyanoborohydride, to this amine. And there's really no isolating the amine, or the imine, sorry. So really the reaction goes straight to the amine product. And you can see that the 4 carbons in our carbonyl species are present attached to the nitrogen of the amine. We can use a variety of amines in this reaction. So if I use the same setup, but I use ethylamine in this case, still with sodium cyanoborohydride, I make the imine first, and the end product is a secondary amine. So here I've made a primary amine, here I've made a secondary amine, and we can do one more example. What if I use ethyl-methylamine along with sodium cyanoborohydride and the original 2-butanone? I can make a tertiary amine. And you can see that my original 4-carbon ketone is present as the new part of my amine. And so you can you could do this 3 times in a row and put 3 different R groups on ammonia to get a totally unsymmetrical tertiary amine. And the interesting thing is that sodium cyanoborohydride is a weaker version of NaBH4. It will not reduce aldehydes and ketones. It will only reduce imines. So we can mix all of these together. The aldehyde and ketone is not destroyed by the reducing agent. Only when we get to the imine intermediate does the reducing agent take action and reduce that imine. Let's look at a few synthetic examples. Maybe your goal is to make this secondary amine via reductive amination. And I can think of a couple ways to do this. We can observe maybe that there is this carbon group attached, and that may come from a ketone of the same shape, sodium cyanoborohydride, and also in this case it would be an amine with an ethyl group attached to it. So we could mix these 3 components together to make that compound. We could also, and so let's just make sure we give that the same sort of treatment. We could also observe that maybe we add the ethyl group instead. That could potentially be a way of adding a group. And so we could go at it from this direction, where the amine is actually this amine, 2-aminohexane, and we add sodium cyanoborohydride, and in this case it would be a 2-carbon aldehyde. I know it's an aldehyde because it's basically attached at the end of the carbon chain, as opposed to this one encircled in red, it's attached in the middle of the carbon chain. That told me it was a ketone. So this could go on by an aldehyde, this could go on via a ketone, and we could also synthesize this from ammonia. Right? The first step could be sodium cyanoborohydride and maybe the aldehyde. The second step could be again sodium cyanoborohydride and the ketone. So we could go 3 different routes here depending on how much effort we wanted to go into to make this product. Let's look at one more example. Here is a tertiary amine that has 3 different groups on it, and let's look at making this from ammonia. Let's start from ammonia and add the different groups. So let's add the methyl group first. So that would be sodium cyanoborohydride and a 1-carbon carbonyl group, which is formaldehyde. And then maybe we want to add the 2-carbon group next. So that would be, again, sodium cyanoborohydride, and now a 2-carbon carbonyl, which again is a 2-carbon aldehyde. And then maybe we want to add the 3-carbon group last. So again, sodium cyanoborohydride, and now a 3-carbon carbonyl species, again an aldehyde. We knew that we needed 3 aldehydes to add because these carbons here are all basically primary carbons or methyl carbons. They don't have any other carbon substituents on them except for one piece. And so we know that this would be an aldehyde at the end of the 3-carbon chain that could make our CN bond via a reductive amination. And so you can see 3 distinct steps. It really doesn't matter which order you go in with these. So you could add the 3-carbon first, then the 2-carbon, then the 1-carbon. It really doesn't matter. And of course, you could have started with ethylamine and then just done 2 reductive aminations to get to this product as well. So there's a variety of ways of producing different amines. I think the reductive amination typically allows us to have the greatest variability in the amine products. So that's the one I would lean towards using if at all possible.